Wouldn't it be cool if you could take a few pictures with your phone and with that turn objects into 3D models? I want to build a 3D scanner that could turn those pictures into objects. The technology itself, it's not really a new one. You can find several videos on YouTube that are at least 6 years old using this technique where you turn 2D pictures into 3D models. Another option would be to buy a 3D scanner. The cheapest ones seem to go around €300. But if I have a phone with decent camera, I might as well try to use it to make the 3D models. After all, there are some videos that say you can make 3D models with any phone, any camera, which I'm not exactly sure is the right info, but we will see that later. To start the design, I first have to model the machine in Blender. The plan is to make a simple machine where I can scan the object with a single button press. The model will be based on OpenScan Mini design. OpenScan Mini is an open source 3D scanner. It's also fairly cheap and seems pretty convenient for scanning small objects. However, it's not really what I need. I want the scanner to be slightly bigger and I plan on using a bit cheaper components. First I have to make a rough sketch in Blender to see how I would build the machine. In the middle is the object that I want to scan. And around the object I want to have a camera track that will always keep the same distance from the object. One NEMA 17 stepper motor will spin the object and another NEMA 17 will spin the camera track. And I will use microservo to automatically take the pictures. And all of this will be controlled by using an ESP32 microcontroller. After the machine layout was done, it was time to model the gears, which I could do in a matter of seconds with the Precision Gears add-on. The gears are fast and easy to do, but how do you actually bend the gears? That is the real question. In its simplest form, I just need one spur gear and one rack gear. First I have to make sure the rack gear is long enough, so I duplicated the original part to make it a bit longer. Then I have to bend the rack gear in order to make the camera track. With the curve modifier I can make the rack gear bend into a circle shape. Once the camera track is starting to take shape, I have to align the objects to the camera track. I think aligning objects into different positions is one of the most important skills to have, and I really don't see people talking about it. My method here is to use Measure It tool to get the right angle of the object. Then I use 3D cursor to center the object to the middle. After having the object in their rightful places, I can finally start refining the camera track. I can use the stepper motor and the gear to see how wide the rack has to be. There is just one small problem that actually occurred to me at this point. How do I actually print an object this big? Well, you just have to make the object smaller. This was obviously a small setback, but in reality not a big deal. I actually noticed it's actually way smarter to design the camera track flat. It's an absolute nightmare to try to modify a curved object, and there is actually no reason to do it, since you can just design the object flat and use the curve modifier later. And I plan on linking these different track parts using M8 3D printed bolts. Aligning the curved object was a bit tricky. I sort of eyeball it since I don't really know how the curve modifier works. And the bolt threads need to be added manually later, since I don't want them to be curved with the object. I think we are on a track to something great, and it's time to 3D print the parts and see how they work. This pretty much used the whole build plate of the 3D printer, and the part came out pretty good quality. It's not really ideal to split the gear system in several parts, but I think this will somehow work out anyway. The different parts are connected by pushing them together and securing them with M8 bolt. I guess the main issue will be if the gaps between the pieces will be too short or too long. I also made a couple of test pieces to see how the camera track would move in its guiding rail. Most likely it's better to have some movement rather than having a tight fit. After this, it was time to get back to modeling. Next thing I want to do is to visualize how I would attach the camera to the machine. I plan on taking the pictures using a mobile phone, to be precise a Pixel 7a. And in order to do that, I decided to model the phone in Blender. It's way easier to visualize the whole machine if you model even the smallest components. I also had to build some kind of holder for the stepper motor. And it's more convenient to model this in two parts. One will be the rail and other will be the stepper motor holder. But later they will be blended together in a slicer and printed in a single piece. For 3D printing, I like this idea of simplifying, modeling one part, then you model another part, and you can just link them together. It's easier to modify and maintain, even if it might look a bit more professional if you did it in one piece. Now we have the camera jack, the guiding rail, and place for the motor, so we can start testing things out. The pieces snap in place easily. Well, at least most pieces. I think there is a saying in woodworking that you measure twice and cut once. Maybe I should measure these things properly next time. It's funny how you can still manage to come across these same problems over and over again, even if you have spent thousands of hours printing and designing these things. Some things never change, like measuring something wrong. I 3D printed the parts again with proper measurements, and now it's time to see how the stepper motor works. And sadly, there are still some issues. I think the gears are meshing properly, but somehow the track doesn't move at all. Once again, I'm left wondering what the problem could be. How the heck do I even salvage this design? I guess there might be too much friction still. Honestly, this was supposed to be a pretty simple part of the project, but you never know where things can go wrong. After doing some investigation, I think the problem was that the spur gear was not measured properly. It was also a bit off-center, so naturally it could not even move. Quite a small problem that caused me tons of headache. But at least the fix was relatively simple. I only had to reprint one part. But will this actually work when I add more parts to this? I'm feeling quite doubtful. I don't know. Should I stick with this plan or try to improve it? Well, of course things never go as you expect, so I had to redesign the motor. I figured out I probably need a bit more torque for the machine, and the easiest way might be to add the planetary gear for the system. I ended up designing a planetary gearbox that should offer around 5 times the torque. Obviously there is a lot of friction in my design, so the reality will not be as much, but it should still be enough. It should be enough because I'm really hoping it will be enough. I don't know why I always end up relying on luck to make this work. Anyway, it was finally time to design a holder for the mobile phone and for the servo motor. The design process for these holders was relatively simple. I already had the objects in place and I just modeled the holders to be around the parts. Quick, simple and easy. At this point I'm thinking the project is probably around 50% finished. I still need to design the electronics, test out the gearbox and actually take the pictures and somehow turn them into models. There is still plenty to do. After the latest design changes, it was finally time to test out the 3D printed planetary gearbox. I wish the design was a bit more refined. But sadly, this is how the things usually go. You start with something, it doesn't work and you just have to somehow scrape up a solution to fix your problems. It's not ideal design since I don't have any bearings and there is quite a bit of friction here. But as always, I'm just hoping it's good enough. It doesn't have to be perfect anyway. I attach all the parts together in this project using M8 bolts. Somehow I have grown to like the idea of 3D printing all the parts and I don't have to search for the right screws or bolts. The sketchiest part of this planetary gear is probably how I attach it to the guiding rail, but I'm sure it's good enough. I'm absolutely gonna lose my mind if this doesn't work. Even though this was a quick fix, the quickest that I could think of. If this doesn't work, I will have to print all of these parts again with a different solution. Would I even have the energy to actually do that? I don't know. The planetary gearbox seems to be doing what it was supposed to do. The rail is moving quite smoothly, and I can finally start to think about the next part of this project, which will be electrical design. I still need to power up all the devices and make a program that automatically takes the pictures. Good enough for now. Time to move on to the next phase. I designed casing for all the electrical components in Blender. The electrical components will be placed on their own case next to the machine. It's easy to remove and add if needed. Then I also decided, hey, why not even do the wiring design in Blender? So I have the models in Blender, I have the electrical connections in Blender. Genius idea. And honestly, it was pretty easy to do and I can easily print out the design. Then I just need to solder some components and some connections are connected with quick connectors. That's how you end up with the design just like in the picture. Then I uploaded the code to a microcontroller and tested out if the things work out next to my computer. The design is a bit messy, but it's the best I can do. And with that, we are finally done with this machine. We are finally ready to take the pictures and make some awesome 3D models. Okay, this is the setup for my 3D scanner. It will take 50 pictures and I'm hoping that I will get a decent 3D scan based on that. But most likely I will still need to do more tinkering to get decent scans, if I will get any at all. Now it's finally time to talk about how do you actually turn your images into 3D models. I plan on using Meshroom. It's a free open source software that you can use to turn your 2D pictures into 3D models. The process itself should be relatively simple. Meshroom also has this manual where it's explained how you should take your pictures and what settings you should optimize in your camera. Sadly, I'm just using my phone and I cannot even change those settings, so I guess I will just skip this part. However, there is one very important thing that you should notice. It also says the image shooting process and the quality is the most important and challenging part of the process. I guess I might have missed this part, but I most certainly did experience it. The process of turning images into 3D model is relatively simple in Meshroom. For my needs there is already an option to use turntable, so the first step is to select the right pipeline and import your images. Then you just hit start and wait for the process to finish, which might take a while, but I have sped up the process. If everything went right, you should be able to see cameras form for each image, which didn't happen for me. And the results for my first scan was absolutely terrible. So next step was maybe I could scan a simpler object. I decided to scan an eraser, but sadly that didn't even compute. I even tried using a different background if that would help to make the scan better, but obviously that didn't work out. I also tried to take the pictures manually, since I really was trying to figure out if my setup was the problem, but manually taking a few pictures doesn't solve at all. Just randomly doing stuff will not get you anywhere. And eventually I did end up having some pretty artistic scans that look pretty decent. So I tried to make the scans work with different pictures, different backgrounds, but I really had a hard time getting a decent scan. At some point I had hundreds of turtle pictures with different setups. What do you do at this point when nothing seems to work? After taking hundreds of pictures, trying out different processes, I finally did get some decent scans. They are certainly not perfect yet, like my pictures are not perfect either, but it's at least some progress. I think the key takeaway is to take enough good quality pictures and you will probably end up with a pretty decent scan. And this is how it looks on Meshroom. It mostly detects the cameras, but there was still some mistakes. After playing around with Meshroom, it was time to try another program, and I decided to try this realityscan. It's also a free software if you make under 1 million revenue in a year, and it seems quite powerful and easy to use. The workflow in realityscan is quite simple. You first select the images you want to turn into 3D model. After that you can mask the images. Once that is done, you align the images, which makes this sort of coast model. Then you can make a preview of the model, which should only take a couple of seconds. Then you can set up the reconstruction region so unwanted parts won't be modeled. After that is done, you can construct the model in normal quality and add texture to the model if you want. After that, you can export the model as an OPG file. I used the same image set in realityscan and Meshroom, just to get the comparison between the softwares. The quality of the models is pretty similar, even though I think realityscan did slightly better job. I think I tried to use around 10 different lighting and background setups in this project, and here are some of the results that I got from those setups. Some scans ended up being quite decent and some absolutely terrible. I tried to scan simple objects and complex objects, and while the results mostly came out fine, it's sometimes hard to capture the small details. So it turns out 3D scanning is not as easy as I would have thought of. I mean, if you take good quality pictures, it seems you get good results. It's as simple as that. But my setup is still very bad and I will have to do some work to get decent scans. Anyway, that's it for now. Bye!